everyone. Welcome to the first podcast in this lovely series with Chapter 4, dealing with triangles. We're really going to focus on a lot about proving things congruent. And so this whole chapter is about congruent triangles. So a very important chapter, very proof-oriented. So please keep that in mind. If you're struggling with your proofs, make sure to come and see me. Today we're going to talk about our key concept is talking about what does it mean to be congruent. So to have congruent figures. Congruent polygons is when their matching parts, their corresponding parts, have to match. So here we have it all color coded here on the screen. So for example, angle A matches with angle E. Angle H would match with angle D, and so forth. And sides would match too, like AB would match EF. Notice that the colors help us with the labeling purposes. DC would be congruent to HG. So when figures are congruent, each of their individual pieces, segments, and angles must be congruent. Okay? Next, this theorem is also called the no-choice theorem, or the third angles theorem. And so this is all about if we have two angles in a triangle that are equal, then the third one has to happen automatically. And if you think about that, it's very simple to see why, because again, they always add up to 180 degrees in a triangle. So if two of the angles pairs are equal, the third one has to be, because the other two are going to add up and you're going to subtract it from 180, which is the same number for the other triangle. So they're just going to coordinate. So again, that's the third angles theorem, or the no choice theorem. So first we're going to start out by doing some matching here this lovely day. And so I'm going to grab my pen. So if we were going to match, here are two triangles. This is a congruency statement, by the way. A congruency statement is when you see a triangle shape, or whatever shape this is, and the letters, and then the congruency, that's the congruent symbol, and then the other shape. And so the three pairs of congruent sides, or corresponding sides, would be like, for example, AC, which would be congruent to DF. And you could even coordinate them with markings, with tick marks. That works lovely. Also notice that AC is the first letter, third letter. So you can do the same thing even if you didn't have the picture. So we could say DF, and that would coordinate. Okay, next, AB, figure out what it would match with. AB is going to match with DE, or look at above. AB 1, 2, DE 1, 2. And mark those. And then finally, then we'd have our last one. So CB, and so since I said CB, then I have to do FE. It's so important to coordinate and to be able to match, just like your shoes, people. And again, you could check it. CB, third, second, FE, third, second. Okay, three pairs of congruent angles. Those are just the angles that would match. So angle A would be congruent to angle D. Angle B would be congruent to angle E. And finally, angle C would be congruent to angle F. And you can check up on top here, first letter, second letter, so forth. I think you'll get the idea on the matching. Very simple. So here we have a particular aircraft, SR-71 Blackbird. And if you look at the wings are very much a lot like congruent triangles. So if we were going to use this idea, how do you think we could figure out how much is the measure of angle D? Well, if these triangles are equal, see how B and E coordinate because they're both 30 degrees? Okay, but what we want to really do is figure out how much D is. So to do that, be careful. This triangle is really this triangle flipped over. So you really kind of need to figure out what does C coordinate with. So C is going to coordinate with its buddy F. And so therefore that's 75. 180 degrees are in a triangle, so therefore D is going to have to be the same as A. So we just need to add our two angles together. Get 105, subtract that from 180, and we'll get 75 degrees. So that's how much angle D is, and also how much angle A is. Can we conclude that these figures are congruent? So in order for figures to be congruent, we need all 6 pieces to be equal. We need 3 pairs of equal sides and 3 pairs of equal angles. That's really important. If we don't have enough information, we can't say they're congruent. So here, if we're looking at this picture, we have a 4 and a 4, so we got a pair of sides, a 6 and a 6, so another pair of sides, and a third pair of sides because of the tick mark. So all the side pairs are good. Okay, now let's look at the angles. A is congruent to E, that's good. B is congruent to D. And this angle has to be equal to the other one because it has no choice. Or it's the third angles theorem. Because since 2 pairs of angles are already equal in the triangle, the third pair happens automatically. Or they would say, Mrs. Cable, wait a minute, those are vertical angles. Those have to be equal. And you're right. So since all pairs of angles are equal and all pairs of sides are equal, therefore, are these triangles congruent? Yes. Okay, let's look at the next picture. So notice we have a pair of sides, AD and CD. Notice they share a side. If they share a side, you can count that as one side because DB has to be equal to itself. That's called the reflexive property. Also, we would know that since this triangle, if you ignore this line here, you'll see that this angle, this side is here and this side's here. That's an isosceles triangle, like this whole triangle. So technically, angle A would be congruent to angle C. But you probably don't, maybe not know that yet. So, do I have enough information? No, there's no way I'm going to get the rest of these angles and sides to be equal. And I can't conjecture anything about B. I mean, they look like 90-degree angles, but we can't assume any of that. So therefore, can I figure that they're congruent? No, we just don't have enough information at this time. Okay, let's put some algebra with it. So here we have triangle ABC is congruent to triangle DEF. I know angle A is 50 degrees, E is 30 degrees, so how much is angle C? Well, if A is 50 and E is 30, this is what I would think. I think, okay, E coordinates with what in the other triangle? See, because we're looking for C, and so who cares what E is? E's in the completely wrong triangle. But if we use our ideas of matching, we can say, oh, E's matches with B, so therefore that's 30 degrees. And then therefore, oh, these make a triangle, so 50 and 30, which make 80. And then subtract that from 180, you'd get 100 degrees. And so that's how much angle C would be. Here's another one. We have quadrilateral ABCD congruent to QRST. We know how much algebra angle A is. It's x minus 10. We have the measure of angle Q being 2x minus 30. How much is angle A? Well, got to coordinate, people. So A would match with Q. Well, since they match, that means they must be equal. They're the same as each other. So we would set them equal. And then algebraically solve. So I'm going to subtract an x, and then I'll have negative 10 equals x minus 30, add 30, and so I'll get x equals 20. And I'm done, but it says find the measure of angle A, so I'm going to have to plug it back in. So x minus 10 was angle A, so 20 minus 10, so angle A must be 10 degrees. You can also do fun things with this involving a proof. And again, before you moan and groan and say, oh my God, it's a proof, it's not going to be that bad. Because again, all we need are 6 pieces of things to be equal to be able to say that the triangles are congruent. So the first thing I would do is I'd put in all my given. So LM is congruent to LO. We have MN congruent to ON, and angle M congruent to angle O. Notice all of it's beautifully marked in the picture, which is great. And so all this is given. Okay, now look at it. We've got, 2 pairs of sides. This pair's good, this pair. We need 1 more pair of sides. So hopefully you notice, hey, they share a side. So therefore, I can say that Ln is congruent to ln. Because since it's in both triangles, it's got to be equal to itself. That's called the reflexive property, because something has to be equal to itself. Okay? So now I got all the sides equal, 3 pairs. Now let's check the angles. Ooh, got a pair, M and O. Got a pair of on the L's. Oop, I need one more pair, but that pair's got to happen automatic. Because, again, if 2 out of the 3 angles are congruent in the triangle, the third one's got to happen because it has no choice. So we have to name him. So angle MNL, can't just call it angle N. There's more than one angle there. And angle ONL. And then that's going to be, again, the no choice theorem. Or we could also call it the third angles theorem. And then finally, now we can say the triangles are congruent because all 6 pieces are congruent. 3 pairs of congruent sides and 3 pairs of congruent angles. So this would just be definition of congruent triangle. So there's an example of a proof. Here's one more proof, and then this is where we'll finish for today. So give it a try. Pause the podcast. See if you can figure it out. It's really not that bad. Well, to do this proof, again, put in the given. We have angle A is congruent to angle D. Again, everything is lovingly marked in the picture already. AE is congruent to DC. I can't get across to you guys, though, as much as possible to make sure to mark your drawings. Now, this one is marked for you, which is super cool. But just remember that that's important. Hey, this proof's really nice. Look at it. It gives you 3 pairs of equal sides. Equal, 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 equal. So we're good with sides. Now we just have to get the angles. So again, this looks like it's going to be a pretty short proof. So hopefully you can realize we can assume some lovely vertical angles in this picture. So angle ABE is congruent to angle DBCY. Vertical angles are congruent. And then next, we can just say, oh, well, angle E has to be congruent to angle C. And the reason I can call them just E and C is because there's only one angle there. So just to share. So that would be your, again, your no choice theorem, or again called the third angles theorem. And then finally now, since I've got all of the angles equal, all the sides were equal, I can say triangle AEB is congruent to triangle DCB, and the reason why would be, again, definition of congruent triangle. Oops, got to put the congruent in there. And that concludes this podcast about congruent figures. And have a great day.